Hello, physics, back again. Starting another lab, right? Starting another lab for energy, right? Or like, well, I'm not going to put in quotation marks. It's not quotation marks. It is conservation of energy. We're going to be looking at why, or I mean, we kind of know why, but we're looking at exactly how much energy gets transformed, removed from an object when it bounces off the ground, right? So we're going to use some kind of sports ball. I think in class I have a golf ball, a tennis ball, lacrosse ball, soccer ball, baseball, softball. I have lots of those just hanging out. Um, each group will kind of pick their own. Obviously, if you're in class, you'll get to do it in class. Fully remote students, you have a couple of options here. You can either film something on your own, right? If you have some kind of sports ball, or like any generically bouncy object. Ideally, it's bouncy, right? I don't want you to take like an apple or something. It's just gonna splat on the ground. It's very boring. But I want something that will you can drop from like say here, and it'll bounce, and it won't make it all the way back up. It should. Perfect magical Christmas land. It would get exactly back up to the point from which you dropped it. However, we don't live in perfect magical Christmas land, so when an object falls to the ground and bounces back up, one of the many reasons we know that it bounces is because it makes a noise, right? So what you're going to do, your goal for this lab, is to determine how much energy is transformed, is converted into sound energy during this collision. The way you're going to do it is kind of similar to how we did the momentum lab. You're going to track an object on LoggerPro. Just going to show you something new on how you can do it and maybe have it be a little bit easier, right? This time we don't need as much data analysis. I know that for the momentum lab you had to plug things in and make graphs and take linear fits. This time all we need to do, if you think about if I hold an object here, right, not moving, then it has gravitational potential energy, which you can calculate based off its height from the ground. And I let it go. It's going to turn into kinetic and potential. More kinetic as it drops. When it hits the ground, it has kinetic, and it converts some of that energy into sound, right? We hear exactly that there's like a thud or a pop or a bounce, whatever you hear. And then it comes back up again, right? So that kinetic energy that it had down here is slowly converting back into gravitational potential because it's rising above the ground. We know from when we talked about an object that you throw up into the air, it goes up and it slows down and slows down, and eventually it stops when it reaches its peak, and it'll come back down again. Right? So when you are tracking your object, you're going to track from... I got monologuing. My screensaver thought it would be a cool time to turn on. When you track your object, you're going to track it on the way down, on the way back up. I would go a little past that highest point, just so that you know you went from where you released it down to the ground, all the way back up to its highest point, and coming back down. And all you need off of LoggerPro is those two heights, that height that you released it from, and the height that it reaches after the first bounce. When you do this, and I'm gonna do an example, insert movie. I have sample movies. I need to look for this. Oh, there's one that's called The Way the Ball Bounces. Maybe I can just use that. Where'd it go? Oh yeah. Well, that works lovely. Okay. I should have used this in class. That's okay. So they use a motion detector, which is wonderful. We're just going to use... Okay. Good. Perfect. So, if you look, this person releases the ball from a certain height. Click, click, click. And it only gets back up to there. And then it'll come back down. So, if I look at this, and I start to track our object, so here is about the middle of the ball, and my mouse is being a little weird here. There it is again. There's again. It's moving a bunch more. Now you can see that this ball actually does travel a little bit out, which is not a big deal. I always pick the center of an object to give myself a lot of like wiggle room when I'm trying to track the object. Alright. gets up to its new highest point. And like I said, I would go a little after it just so that you can see. Alright, so there's a few things that I can do here. The first version of this that I could do, I could look at my graph, and right now I have not set a scale, so I should go back to my video, let's do this properly. Right? Let's set an origin, and let's say that the origin is about the ground, and let's set a scale. Let's say that this individual is, I don't know, 1.2 meters tall. Arbitrarily. And now that I've done that, I know that this ball was dropped, and, oh, another thing, right? It's the first point is time equals 0, that way the LoggerPro graph knows that I started at time equals 0. So I know that if I go back to y, right? I know that my first y position was 0.7877 meters, that's how high it was above the ground. And then this next highest point was 0.5458 meters, right? So I could read the graph. Alternatively, over here on this toolbar, I have another option, and if I hold my mouse over it, you should see it says photo distance. So the other thing that I can do, now that I've set a scale, I can take the photo distance. I can click and drag from here down to the floor. I should get about 0.7877. So according to the video, it's only 0.7839, right? And then I could do the same thing. I could take the photo distance from this highest point here, right, wherever it was, all the way down to the ground. And if I do that with a reasonably straight line, I get 0.5477. So again, very close. These two numbers are very close to the numbers on the graph. So I feel pretty comfortable using either one. But it's just, this is a way of measuring an exact distance. When you are recording your video, I just realized there's a third option. I didn't even finish. You can either group up with a group that did it in class. You can record your own video, and if you record your own video, the only thing to make sure of is that you're kind of dead on, right, with the with where you are dropping your object. Make sure there's no kind of angle, otherwise these distances will be a little skewed, right? Or the third option. Actually, I guess the third option is kind of the first option. We have that pass program that will, like, connect you with someone who's in class, so that may be an easier way than trying to just, like, send a bunch of emails and say, hey, do you have anything that I can use for the lab? Like, talk to whoever, I don't remember who's in charge of the pass program, but talk to them, and they should be able to get you set up with someone who's make sure you get someone who's in our section, because there are 2 honors physics classes, so just make sure you have someone who's in class for mine. But yeah, everybody, there are a few different groups there will probably be a few different groups. Just, I'm anticipating how many people are in each class. With a few different videos, so we'll probably do 3 or 4 of the different sports balls. But again, if you have this height, right, this was the original height, and you have a new height, you can find potential energies at both places. This is going to be a very straightforward, very simple lab. I just want you guys to kind of recognize and realize where energy goes. Conservation of energy is a real thing. It's not something that you can violate. This ball, the sports ball, didn't lose energy. I think this one's a kickball. I couldn't exactly see what it was. I just assume it's a kickball. It's got that, like, dodgeball color to it. And this is like this looks like a very mid-90s video. But using conservation of energy, determine how much energy is converted into sound energy upon the first bounce, right? There aren't a terribly large amount of things that could have gone wrong, but do try to mention something that could have gone wrong, mention some kind of improvement that you could make, right? The things that could have gone wrong go in your analysis, the improvements that you could make go into the conclusion. But yeah, again, straightforward lab. The video process is also, this one's kind of nicer. There's one more energy lab that I do want to do. It might wait until after the break. We'll see. Kind of how things progress this coming week, which is like the 14th to the 18th. Hoping this video goes up. Anyway. But yeah. Alright. If you have questions, please send me an email. Otherwise, I will see you next time in class. Take care, kids.